Alright, so in this problem, I have 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. So I'm going to first start by rewriting 20 as 19 plus 1. So now I have 2 to the power of 19 plus 1 minus 2 to the power of 19 is equal to 16 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of 19 plus 1, and this is going to equal 2 to the power of 19 times 2 to the power of 1. Now I have this minus 2 to the power of 19 is equal to 16 to the power of x. Now from here, if I factor out 2 to the power of 19 from my left-hand side, I get 2 to the power of 19 times 2 to the power of 1 minus 1 is equal to 16 to the power of x. And 2 to the power of 1 minus 1, that's simply equal to 1. And anything times 1 is itself. So I have 2 to the power of 19 is equal to 16 to the power of x. Now, 16, that's the same thing as 2 to the power of 4. So now I have 2 to the power of 19 is equal to 2 to the power of 4 to the power of x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 4 to the power of x, that's going to equal 2 to the power of 4 times x, which is also 2 to the power of 4x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 19 is equal to 4x. Now we have a simple equation here. All I have to do is divide both sides by 4, and I get x is equal to 19 over 4. Now, to check, my original equation was 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. Now, 2 to the power of 20 minus 2 to the power of 19, we already know that's 2 to the power of 19. So we get 2 to the power of 19 is equal to 16 to the power of 19 over 4. Now 16, that's the same thing as 2 to the power of 4, so now I have 2 to the power of 4 to the power of 19 over 4, and these two 4's cancel out, so I get 2 to the power of 19 is equal to 2 to the power of 19. Alright, so in this video, I'm going to solve the equation x to the power of 12 minus 1 is equal to 0. So to solve this, I'm going to first rewrite this as x to the power of 6 to the power of 2 minus 1 squared is equal to 0. And the reason I'm doing this is so I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into x to the power of 6 plus 1 times x to the power of 6 minus 1 is equal to 0. So this gives me two equations. I get x to the power of 6 plus 1 equals 0, and x to the power of 6 minus 1 equals 0. Now I'm going to do the same thing again. I'm going to rewrite x to the power of 6 minus 1 equals 0 as x to the power of 3 to the power of 2 minus 1 squared is equal to 0. So I can use this property again and get x to the power of 3 plus 1 times x to the power of 3 minus 1 is equal to 0. Now, for x to the power of 3 minus 1 equals 0, I'm going to rewrite this as x to the power of 3 minus 1 to the power of 3 equals 0, so I can use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So this turns into a minus b times a squared plus a plus 1 is equal to 0. Sorry, this turns into x minus 1 times x squared plus x plus 1 is equal to 0, which gives me yet another two equations. So now I have x minus 1 equals 0 and x squared plus x plus 1 equals 0. So for x minus 1 equals 0, all I have to do is add 1 on both sides, and I get x is equal to 1. And for x squared plus x plus 1 equals 0, I can use the quadratic formula. So by using it, I get x is equal to negative 1 plus or minus the square root of 3I over 2. So these are two more solutions. And now we aren't done yet because we also have to solve these. So now I have x to the power of 3 plus 1 is equal to 0. And I'm going to subtract 1 on both sides, so I get x to the power of 3 is equal to negative 1, meaning x is also equal to negative 1. So this is another solution. Now for x to the power of 6 plus 1 equals 0, I'm going to again subtract 1 on both sides. So I get x to the power of 6 is equal to negative 1. And if I take the 6th root, I get x is equal to 6th root of negative 1, which is equal to negative 1 to the power of 1 over 6. So now, the 6th root of negative 1 is, say, we know that I is equal to the square root of negative 1, which is equal to negative 1 to the power of 1/2. So negative 1 to the power of 1 over 6 is the same thing as negative 1 to the power of 1/2 minus something. So now 1 over 6, or I should say 1/2 minus 1 over 6 is equal to 1 over 3. So 1 over 6 plus 1 over 3 is equal to 1/2. We know this, meaning we have negative 1 to the power of 1 over 6 and this plus, or sorry, I should 1 over 2 minus 1 over 3 is what we can rewrite 1 over 6 as. Now, this is the same thing as 1/2 plus negative 1 over 3. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So this is going to equal negative 1 to the power of 1/2 times negative 1 to the power of negative 1 over 3. Negative 1 to the power of 1/2 is the square root of negative 1, which is equal to I. So we get I times negative 1 to the power of negative 1 over 3, which is the same thing as 1 over negative 1 to the power of 1 over 3, which is equal to negative 1. So I get I times negative 1, which is equal to negative I, which is my final solution.